So this is another question from NEET 2018 examination. Question number is 142, where the question is very simple. What you need to do is, so there is a column where various metal ions are given, okay, and there is another column where magnetic moments are given, okay. So what you need to do is, you need to calculate the magnetic moment and match with the column 2, right? And we know that magnetic moment is nothing but under root n plus 2. The formula is n plus 2 Bohr's magnetron, right? And where n is the number of unpaired electrons. So what we need to do is, we need to find out that what is the number of unpaired electron in each of these metal ions, okay. So let's start with the first, which is cobalt plus 3, okay. So we know that for cobalt we have how many electrons, how many unpaired electrons? So we have for cobalt, what is the electronic configuration? What is the atomic number? Atomic number is 27, right? So we will have 4s2 and 3d7, the valential electronic configuration, okay. And if we want to go for plus 3, what we will be left is 4s2. So these two will be gone straight away. We will be left with 3d6. So that means we have 6 electrons, and when we will fill these 6 electrons into 5d orbitals, because ligands are not present, so definitely all of them will be degenerate, and when we are going to fill them up, so 3, 4, 5 and 6. So we are left with 4 unpaired electrons, right? So if we calculate the magnetic moment for this quantity for cobalt plus 3, it is simply 4 and 4 plus 2 Bohr's magnetron. So that means 4 into 6, that means 24 under root 24 Bohr's magnetron, okay. So for A, I have got root 24 Bohr's magnetron. Okay. Now let's calculate for the second ion that we have. The similar process we need to do for chromium. Okay. For chromium is we have 3d2, so it is 24, right? So 3d4, pardon me, 3d4 and 4s2. Okay, this is the electronic configuration, and when I will take chromium plus 3, it will become 3d3, okay. And all the 3 electrons will be filled here, so all of them will be unpaired electrons. So if we calculate the magnetic moment, we will have 3 into 3 plus 2 Bohr's magnetron, and that will give us a value of 3 into 5. So that means under root of 15, okay, under root of 15 Bohr's magnetron. Okay, so for chromium, that means for B, we have got this option root 15. So that means root 15 Bohr's magnetron. So that means option number 5 is correct for B. Option number 4 is correct for A. Okay, let's go back for C. C is Fe plus 3. Okay, so we have Fe plus 3, and iron we know is atomic number is 26, so I can write for iron, I can write the electronic configuration as 3d6 4s2. Okay, if I want to write for iron plus 3, I will get it as 3d5. Okay, what will happen now for 3d5? That means all the 5 electrons are unpaired. Okay, these are filled here, right? So all the 5 are unpaired. If you go on and calculate the magnetic moment, it will become root of 5 into 5 plus 2 Bohr's magnetron. Okay, so that means it will become 5 into 7 under root of 35 Bohr's magnetron, right? So for C, we got second option as the correct option. So that is root 35 Bohr's magnetron. Okay, now coming to option number D. Option number D is nickel plus 2, right? So nickel is 28, we know. Okay, so that is 3d8 4s2. Okay, and if I am going to talk about nickel plus 2, so for plus 2 it will become 3d8. Okay, and for d8, if I fill 8 electrons, so 1 2 3 4 5 6 7 and 8, so I will be left with 2 unpaired electron, and if I want to calculate the magnetic moment, it will become 2 into 2 plus 2 Bohr's magnetron, that means 4 into 2, and it is going to be root of 8 Bohr's magnetron. So option number 1 is correct for D. Okay, option number 1 is correct for D, that is root 8 Bohr's magnetron. Okay, so what you need to find out in the question is this. Okay, so there is one option, I guess option number 2, where it is given as A matches with 4, B matches with 5, C matches with 2, and D matches with 1. Okay, so this is what you need to find out. A little bit lengthy, but question is very simple. What you need to figure out is what is the atomic number of all these metals, and when you put them into the proper oxidation state, how many unpaired electrons are present.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.